You were there, right? Okay. So what we were saying is that the mass of hydrogen atom was considered as 1 AMU. Okay, mass of hydrogen atom was considered as 1 AMU. Now, by considering the mass of hydrogen atom as 1 AMU, we calculated the mass of the other atoms. How? That suppose any atom, how much heavier it is in comparison to the hydrogen atom. Just suppose if we think in this manner, there is a balance. In one side I had kept nitrogen, one nitrogen atom, and we have got hydrogen atoms to balance it. Okay, because that's the standard one. So we saw that this balance is balanced when there are 14 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 hydrogen atoms if we keep, that is balancing with the nitrogen atom. So can I say that the mass of this nitrogen atom is 14 AMU? That is how we tried to balance it. That is how we tried to find out the atomic mass, or you can say the relative atomic mass of the atoms. By considering what as the standard? By considering the hydrogen as the standard. But taking hydrogen as the standard had so many of difficulties. Okay. So it could not help us to find out the atomic masses of all other elements, okay, of all other elements or all other atoms. Hence, this needed the modification. The modification was done by considering oxygen, as the standard one. They took, standard means they considered the mass of oxygen as 16 AMU, and they measured the mass of the other atoms by considering the oxygen's mass at 16 AMU. Okay, suppose carbon's mass, leave out carbon. Nitrogen's mass they found is 14 times greater than, please understand it, 14 times more than hydrogen. 14 times more than hydrogen. Fine. So they told that the mass of the nitrogen is 14 because hydrogen is considered as 1. Then in terms of oxygen they found nitrogen's mass as 14 times more than 1/16th mass of oxygen. 1/16th. One oxygen has got 16 AMU. So 1/16th of oxygen means 1 AMU. 1/16th of oxygen means 1 AMU. And they found nitrogen is 14 times more than that. 14 times more than that means what is the mass of nitrogen? Nitrogen's mass has been found to be 14. Same way as that found in hydrogen, exactly the similar way it is found for the oxygen. But the problem has been found with oxygen, taking oxygen as the standard one also. Because it had been found that oxygen is also not reacting with every element, and it is not possible by considering the oxygen at the standard one to find out the mass of the other atoms. And hence the last concept, the latest concept has come, and we are calculating the atomic mass by taking that as the standard, and that is nothing but carbon atom. Okay, carbon atom's mass is considered as 12U or 12 AMU. Okay, 12 AMU, and by considering the carbon atom's mass at 12 AMU, we calculated the mass of the other atoms. So whatever is the mass, suppose an atom is A, whatever is A, it is how much time heavier than 1/12th of a carbon atom is the atomic mass of it. 1/12th of carbon atom means 1/12th, so 12 AMU means one atom. 1/12th of carbon atom, 1/12th of carbon atom equal to 1 AMU. So I told that one particular atom is how much heavier than 1/12th of a carbon atom. Okay, 1/12th of a carbon atom, how much heavier than that? Okay, that is the atomic mass of what? That is the atomic mass of the atom. Okay, this is the final concept of atomic mass, and accordingly we found the atomic masses of all the atoms And the unit for atomic mass is, again I am saying, is nothing but atomic mass unit. Atomic mass unit. In short, we write it as mu, or in further short, we also write it as U. Okay, so that is what is relative atomic mass. Again I am saying, relative atomic mass is nothing but atomic mass of the substance. Now why do we use the relative term? Because we are measuring it with respect to what? We are measuring it with respect to certain standard values. Okay, and that standard values were initially taken as hydrogen. By considering hydrogen's mass as 1 mu, we calculated the mass of the other atoms, but not many atoms could be measured by considering hydrogen. Then the standard was changed. The standard was changed into oxygen. Okay, that oxygen was considered as the standard one, but oxygen's mass had been taken as 16 mu, and by considering that as 16 mu, we calculated the masses of the other. Then we found out what? Then we found out that that oxygen is also not very good enough for measuring the masses of the other atoms or all other atoms. So we changed the standard, and we changed the standard into carbon. We considered the carbon atom's mass as 12 mu. So whatever is the mass of the atom, 1/12 of each carbon atom, okay, is called the atomic mass of it. Okay, fine. Now next topic. So that's the first topic, and that was the most important one in this, out of this 4, because if you understand this, there is nothing else. So atomic masses will be given to you. It's not that you have to remember. Okay, very common ones you have to know. Simple common ones like hydrogen's atomic mass is 1. Okay, oxygen's atomic mass is 16. Nitrogen's atomic mass is 14. Then carbon's atomic mass is 12. Some common ones you have to know. Okay, remaining whatever complicated ones are there, that will be given to you. Simply that will be given to you. Okay, fine. Next is molecular mass. Next is molecular mass or molecular weight. Molecular mass or molecular weight. Now what is molecule? All of us know. Okay, suppose I am talking of sulfuric acid. Sulfuric acid. The molecular formula of sulfuric acid is H2SO4. It's very simple, nothing is there. Okay, H2SO4. Okay, you already know how to write down the molecular formula. Already we know this. Now if I ask what is the mass of it, mass of this molecule, that is what is known as molecular mass. So molecular mass is what? Molecular mass is nothing but the mass of one molecule. Fine. Now this sulfuric acid contains how many? What? It contains what? It contains 2 atoms of hydrogen, 2 hydrogen atoms, 2 hydrogen atoms. It contains 1 sulfur atom, and it contains 4 oxygen atoms, 4 oxygen atoms. Clear? Now we know the mass of hydrogen atom, we know the mass of sulfur atom, we know the mass of oxygen atom. If we just add these masses, that will be giving you the mass of the molecule. Simple. So what is molecular mass? It's the summation of the atomic masses present in that molecule. It's the summation of the atomic masses present in that molecule. For example, hydrogen, you know the atomic mass is 1. How many of the hydrogen is there? 2 of the hydrogen is there. So I am going to write 1 into 2. Plus sulfur. There is only 1 sulfur, and the atomic mass of sulfur, as I told, it will be given to you. So don't worry about that. Okay. Atomic mass of sulfur is 32. So 1 into 32 plus 4 oxygens is there, and what is the atomic mass of oxygen? It's 4 into 16. So that much, obviously these are all in AMU. So the molecular mass will be also in AMU, or you can write it in U also. So that is equal to how much? 2 plus 32 plus 4 16 is 64. Okay. So if you calculate it, it is coming at 98. Okay. 98 AMU. That's how to find out the molecular mass. Very simple. So it's just the summation of what? Just the summation of the atomic masses. The common ones atomic mass, just for 5 common ones atomic mass you have to know, or you will know automatically. The other atomic masses, whatever is there, that will be given to you. Fine. That's the second topic. Now the third one is percentage composition. The third one is percentage composition. Percentage composition. Third one is percentage composition. What is percentage composition? Please understand it. It's also very simple. Percentage percentage composition. Percentage composition. What is percent? Percent. Per means out of. Cent means 100. Percent means out of 100. It's nothing. Percent means out of 100. A particular substance present in a molecule, out of 100, how much of that is there is called the percentage composition of that particular element. For example, let me just take an example, then you can understand it better. Suppose CO2, carbon dioxide. Okay, CO2. Now, what is its molecular mass? We know atomic mass of carbon equal to 12 and atomic mass of oxygen equal to 16. Whatever I am writing in mu or U. Okay. So 12, 1 into 12, so that is 12 plus 16 into 2, right? 2 into 16. So 2 into 16 means how much? 32. So 32 means that is total is how much? 44. So out of 44, how much carbon is there? 12 carbon is there. Out of 44 gram of or 44 mu of carbon dioxide, the amount of carbon is 12 mu. Now percent means what? I told out of 100. So out of 100 mu of carbon dioxide, how much of carbon is there? 12 divided by 44 into 100. So that you can find out whatever value you are getting, that much percentage is the percentage composition. Simple. That is what is percentage composition. Okay, one more example I am taking. So you do it with me also. Just one more example. For example, suppose calcium carbonate. I am taking this example for a reason because it is easy to calculate. That is why. Calcium carbonate. First of all, we have to find out its molecular mass, right? Okay. Calcium's atomic mass is 40. I am giving you. Carbon's atomic mass is 12 and oxygen's atomic mass is 16. Okay. So let's find out what is the molecular mass of calcium carbonate. So it is 40 plus 12 plus 3 into 16, right? So that is equal to 40 plus 12 plus 3 16 is 48. So that is equal to, if you see, it is 100. So total mass of calcium carbonate is 100. Out of 100, how much of calcium is there? 40 of calcium is there. Out of 100 only it is there. So you don't have to calculate out of 100 how much there, because this molecular mass is already 100. If it is something else, then we have to find it out of 100 how much is there. So out of 100, calcium is 40. So what is the percentage composition of calcium? It's nothing but 40%. What is the percentage composition of carbon? It's nothing but 12%, because out of 100 only 12 is carbon. And out of 100 how much is oxygen? 48 is oxygen. So what is this percentage composition? It's 48%. So hope you understood the percentage composition also. Yes. So these three topics is done. The last topic we are going to do is empirical formula and molecular formula, but just in the next session.